You're listening to Techsuite for the C-suite, where we bridge the gap between technology and executives. Hey, welcome, Cassie. Thank you so much for joining. Hope you're well.
Thanks for having me. Doing great.
First of all, I'd like to give a shout out to you, especially on Farcaster, for being first of all so technically in depth if the with the answers you gave. Also, in general, just with the overall explanations. Like anytime there's somebody who seems to have a questions about what you're building, Farcaster, anything in the blockchain space, I really enjoy reading your answers. So thank you for that. I'll also have your Farcaster in the description, so people should go to the cast and replies because I see you're mostly active there.
Yeah, I don't use Twitter.
No, I've also restrained my Twitter heavily. Like over the last 6 months that I've been on Farcaster, like you've been on way earlier, my Twitter usage has now slowly degraded. Uh,
Yeah, major quality of life improvement.
no, it is. I also asked the same question on Twitter and Farcaster about technical stuff or just general blockchain things, and there always seem to be with the channels giving you more reach than your following. So it's more like a topic themed conversation. You're just getting answers from people who actually take time to think about the question. While on Twitter, some people just don't take the time and then not respond, or you get like one or two questions. And also, I've kind of the same follower range, like around 400 on both. So that's there you can really see, okay, the channel's working to increase the actual reach, which is
Absolutely.
really cool. Awesome. So, just in general, before we dive into your background, how would you explain blockchain to an executive who has next to no prior experience or knowledge in the field?
So that's going to depend on the executive. If I'm talking to somebody who is a CTO, so they have more of a technical background, I'd approach it a little bit differently than somebody who is like a CEO or CPO or whatever. For a CTO, I would go a little bit more in depth, but focus initially on a broader definition. This isn't technically an accurate one to all of them, but essentially it works like this. You can think of it as a way of tracking changes to a some kind of sequence of events, and whether it's like financial transactions or just general state, like think of like a generic state machine. You're essentially taking all of those state change events or those transactional events, and you are capturing them in a deterministic way that is in you could kind of think of it as a directed acyclic graph of events captured in a way that everyone can universally agree upon. To a CEO, or after I've said that to a CTO, and then they're wondering what that actually
Yep.
means, um, I would say that essentially what that provides you is a way to guarantee truthfulness, like the fact that these events have transpired, whether these transactions on a ledger have transpired or just the ultimate state of running an application, that you can guarantee that universally everyone has agreed on these sequence of events being true. And that has a very powerful ramification. A lot of times in business, when you have like just simple processes like accounting and like accounts receivable and accounts payable, those distinct departments are often kind of running around like chickens with their heads cut off in terms of trying to actually like reconcile things. So you'll have like these really bespoke processes where you have one department at one company and another department at another company, perilously sending each other PDFs that are just like ultimately trying to come to the conclusion that both parties have reconciled their books. Or you have like a fulfillment like facility that is trying to ensure that they have properly fulfilled an order and have sent it out and it's dispatched to the right transport and all of those things. All of those things are just simple business processes that every business has to leverage in how they actually maintain their business. But there's lots of ways they can go wrong, especially when you're interacting with other companies. What distributed ledger technology enables is a way that multiple parties can come together and agree on the sequence of events and feel that everything has been carried out truthfully to the best of everyone's knowledge.
So you're basically saying we don't have consensus or we don't agree on anything being truthful, but there's a system which guarantees it where we don't have to talk as much and communicate. So we kind of have auditors without paying for auditors. Is
Exactly.
that what I'm? what I'm hearing?
Exactly, yeah.
And that these auditors just don't need to be in a financial sense at all. They can be whatever I can compute, right?
Absolutely.
So if I have a backend, for example, and I want to know if some other company is running the actual thing they promise, that also guarantees it and covers it?
To a certain degree. That's where you start to get into the deeper questions of cryptography. Like, for example, if you are talking about a public ledger, obviously two companies wouldn't want to share their books with each other. That would be something that is a
Yeah.
non-starter for many companies. So then you get into the questions around privacy, and that's something that is a lot harder to explain. ELI
Yeah.
five to executives in general sense, but what you're trying to do is you're essentially trying to leverage extreme probabilities with math to assert that something is true without revealing what the actual knowledge is. And that's where you get into things like zero knowledge proof, CK snark, CK starks, all of the above.
So you're basically getting into, okay, well, there's a non-zero chance, but so low that we basically can ignore it, probability of sharing the book, but we can still do all of the aforementioned without basically opening up the full book.
Correct. You with a zero knowledge proof, you wouldn't have to share any of the book, and the probability is not even small enough to consider. Like a normal human being will not ever encounter this probability because we're talking about like a chance of one in units I don't even know the word for.
Well, the typical comparison I learned in university is you would aim for the length of the sun existing when you're trying to compute something or compute a proof.
Yeah, it's the probabilities are so astronomical indeed that you would actually find yourself locating a single atom in the universe first before you would successfully find a colliding value that proves true.
and and before we dive into that whole world, because I know you're building in that space exactly, um, how did you actually start to get interested into the whole blockchain thing, and how did you actually dive so deep?
So I'm definitely a bit of a odd duck in this space. I'm a college dropout. I actually got involved in crypto right at the beginning. I was a member of the mailing
Yeah.
list Metzdowd when in 2008 that white paper showed up for Bitcoin, and so it was very interesting. It wasn't the first proposition of digital cash. There were papers before that, Wei Dai and many others, that were trying to come up with a way to create digital cash in a trustless and transparent way. There was a lot of focus on things like using trusted execution environments, but nothing had before that point had a trustless type of execution model. And so I was really excited about this possibility, and the amount of people that were just absolutely trashing it in that mailing list was hilarious. And so
Wait,
it
so
was interesting.
in
And
that mailing list, so you have a mailing list where basically people interested in that whole concept in 2008 are on, and they're crushing the actual thing.
Interested in cryptography. Metzdowd mailing
Okay.
list is a cryptography mailing list. So it was actually mostly traditional cryptographers who didn't necessarily like the high skepticism is a common component of cryptographers, needs to be, otherwise things aren't secure.
Yep.
But at the same time, yeah, the proposition was something that was relatively unique, and it definitely got a lot of skepticism, especially because at the time, all that was there was the white paper. There wasn't code.
Yep.
So a lot of people, they didn't have a full mental model of how this worked. They just had a white paper to go off of, which talked more generally. So it was interesting to see that. And then in 2009, the code was public, and so a lot of people started jumping in for CPU mining, and that was where I jumped in, and it was it was thrilling. Like people were making digital cash, and so I was excited about this prospect. But at the same time, I wasn't skeptical in the traditional sense. Like I was obviously participating, but I was skeptical in the I don't think this is ever going to really take off. But at the very least, I get to be part of a cypherpunk part of history, and and play with this digital money. And so yeah, that was the fun times. And then, you know, my computer, I was running like this like hacked together machine that had like server grade drives in it, which unfortunately were Hitachi Desk Stars, aka Death Stars. And I lost those drives and all the Bitcoin with it. And so you know, it was like 2010, and I was just like, okay, well, I can wash my hands of this and I can go away. Um, and so I stayed back in my like fintech industry where I was
Yeah.
working, and like kept a pulse on things in the research space, but didn't do anything directly until a little bit later. That was about 2016.
So what did you actually like follow in between? Because most of the people I talked to joined either in 17, 20, 21. I myself am more in the 21 class because in 2016 when GPU prices rose, I was, well, not familiar enough with terminal and all that to keep mining, and the GPU being utilized meant I couldn't play Counter-Strike. So I dropped out of Ethereum mining at that time. But at that time, didn't you have to even compile the software to run like Bitcoin and the kind of miners?
Yeah, at the very beginning, like all you had to work with was a public code base, and Bitcoin was especially rough around the edges at the very start. Ethereum's tooling was a little bit easier to deal with, simpler language, simpler dev environment. But ultimately, yeah, it was definitely like if you didn't have development experience, you were going to have a bad time. You'd have to go off of somebody's guide. But I'd been a software engineer like from childhood. So that was not really an unusual concept for me.
How did you get into software engineering from childhood? Like I know from myself, it's been my dad kind of like being like, oh, you can't just video game all the time. You have to actually know how it works and just at least try it. And I stuck with it. Like, how did it go for you?
So I want to say the first application I wrote was when I was about 7 or 8. It's a little fuzzy. So I got really interested. Like I wanted to be a game designer when I was really
Yep.
young, because like I loved video games and I wanted to build them. And so I got interested in video games that had like hackable scripts, like any kind of scripting language that made it easy to like mod out and stuff. And so I kind of fell into like these communities, like little pocket communities of message boards where people were building scripts for different games, or like ROM hacks for video games from the consoles and stuff. And so that was my break into all of it, was just like being deeply interested in taking something that already existed and making it cooler. And afterwards, then my parents ran a business, and I started building out their like web portal to manage their inventory and handle sales. And I just never stopped coding.
Wait, was that a similar experience to early blockchain? The building of the web portal, because it's not like today where you can just spin up a Stripe API, hook up some AI generated front end, and get it to work.
Yeah, you did have to actually get a good sense of double entry accounting. So I know that's not like a typical 11-year-old's experience, like cracking open the books on how double entry accounting works. But like for me, that was just where I ended up. I wanted to make games, and I ended up tackling the biggest game, which was the economy.
Well, yeah, the economy being a game is something you really see in crypto. Like the truest social experiment an economist could dream of, I think, is highly liquid crypto coins, whereas the highly illiquid ones is, I think, way too manipulated to see it. To, like it's too raw, but then you have the pump and dumps and all that, so you can still kind of experiment with it. But the like I would say 2020 to 2022 era is a nice case study for what would happen if there's no regulation in financial assets, which we also had way before, so you could just read the history books. I found those kind of comparisons interesting to see what regulation they have put into banks that will likely follow in DeFi and the whole crypto space. So is that also a game thing you've been following, or?
So there's two threads to that. Like there's obviously like the traditional, you know, cypherpunk types that are just like none of this, none of this. Like I don't care that you want regulation in this. The whole purpose of this was to be anti-authoritarian, and that's
Yeah.
a totally valid perspective and one that I share. But at the same time, I'm also a realist and know that like if businesses want to adopt this, you have to have some way of ensuring compliance. And I mean, there's some degree of that is like archaic law that makes no sense. You can actually certify that transactions are valid and people aren't printing money because the ledger is public and the protocol rules
Yep.
are standardized. But tracking the actual transfer of funds is something that businesses do have to care about. And for better or worse, there's, ways to do it, but like the legislation that exists encourages something a little bit more scrutinizable than just simply being a proof.
Or just a wallet at risk that it was generated somewhere. Like even in the traditional system where you can just have a cash business, where then no regulation kind of applies. Like if you're a barber shop, like everyone knows that most barbershops have two books. One that you can't see, where nothing is written in it, and the other one that is used for tax purposes. Like not accusing all barbershops, obviously, but they're examples. Just looking around. Thank you. No, not going deeper. But in crypto as well, you kind of have this cash-like experiment because of all this anarchy, where it initially also comes from, and where I think also should go more into, but you have the regular players playing in the space that also need to have the digital money kind of scrutiny that we have now with credit cards and everyone knowing your exact details and all of the audit trails being so deep that law enforcement can basically just trace funds from anywhere to anywhere unless you use cash again. But we're like most economies are getting rid of cash. In Europe, Germany is one of the like big countries where cash is still ruling, while in the north of Europe, you just basically never see cash. So that is also interesting to go into because if you're saying, well, you kind of have both, how can you actually combine the two, or is there even a way to make it compliant for businesses?
To make it compliant for businesses but remain private.
Well, or just have the ability to just use it at all, right? Because if you could say, well, you have to prove, most states would like to have you prove to them that the money is not laundered.
Yeah. So there's a couple of different things, and this comes back around to the challenges that businesses face. Like they can recognize the benefits of distributed ledgers, blockchain, or any other kind of crypto alternatives, but the thing that always is like a thorn in their side is like I can't reveal my books to the public. I can't like have a full traceable ledger of all my vendors, suppliers,
Yep.
all my contracts. That's a non-starter for me. And so like they can understand like the benefit, but at the same time that is a problem. So like solving the problem of how do you have businesses be capable of like utilizing this technology effectively but also retaining privacy and compliance, like it sounds like these things are at like direct ends with each other, but the reality is that it's not. Like there is the existence of zero knowledge proofs. There is the existence of privacy preserving technologies that enable you to basically get the best of both worlds. Comes at the cost of speed, but it is basically how you can achieve that ultimate goal. And so what usually ends up happening is you end up having a public ledger that is just simply a collection of commitments rather than the actual data that is being reconciled between two parties or settled to some kind of book somewhere. And so what happens in that scenario is you are simply taking that constant stream of provably true commitments and using those to create your proofs and assert the validity of whatever statement you are wanting to make to be true. So whether it's I possess $500 or I sent you $50 yesterday and you now have the need to send me like 5 widgets. I don't know, like these kinds of things you can model out in that kind of context and prove as essentially zero knowledge proofs.
So you're basically already going into the whole layer two kind of, oh, we're just using it as a settlement layer debate.
I wouldn't
Um,
necessarily say layer two. I think that layer twos, in the case of like the Ethereum context, it's kind of a necessary evil because of the slowness of the layer one. But Zero knowledge proofs
Yeah.
don't require a layer two to be valid.
No, what I was getting to is like, well, the whole layer two thing doesn't need to be a blockchain. So if you have a compute system outside of that that just commits proofs, that could also be considered a layer two to the actual blockchain you're using and committing to. Well, layer two is basically just go ahead and make sure that their transactions are the thing being committed.
Yeah, it kind of depends on how you're referring to things. Like if you just mean in a general context where you have like layer one is settlement, layer two is execution,
Yeah.
then that doesn't have to actually be like two discrete networks. It can actually be like one kind of whole picture. And in a way, Ethereum kind of is that in of itself because you have consensus separated from execution now.
Yeah. But then the execution layer of Ethereum itself isn't really working to be that speedy. Just make sure you have commitments and instant finality. Where Ethereum then thinks, okay, we should take the layer twos, while other solutions like Solana and different chains think, okay, we should need speed on the layer one, while still otherwise being kind of similar. And in general, I think we're going to see new solutions that either work together with the ones we already have, just because of necessity of network effects, while also just if I'm looking at the whole Ethereum landscape, layer two still have ways to go, and then actually just be used, and we don't have to deal with that anymore.
Yeah, there's a lot of different trade-offs at play. Solana gets the advantage of being fast because they have really strict validator requirements about what kind of hardware can be leveraged.
Yeah,
It's not significantly different of a design. The proof of history model versus like proof of stake or proof of work is kind of its own thing, and that's partially what causes the validators to be so large in cost. But at the same time, like at the end of the day, it's still a blockchain. Um, at the same time, like the notion of a need for layer twos being what they are, being what you need to do to achieve scalability on slower networks, yeah, it's just all a series of trade-offs.
what kind of trade-offs are you thinking of specifically when you talk about layer twos?
So layer twos are essentially accommodating for two problems that exist on Ethereum. One is execution speed, the other is total block space. While Ethereum, in a logical context, has very massive block space available to it, the costs of it are just like astronomical in comparison to having settlement off chain.
So then when you go into block space and well just the basic cost of using it, isn't that a general negative of the whole blockchain space at all?
There can be, and I mean that comes down to the network specifically, because there are definitely networks that are much cheaper. I mean, Solana's execution fees are much cheaper. They impart storage rent, but the storage rent costs are also pretty negligible.
But then don't you have the trade-off of, well, okay, now we can still ramp up the cost just by having it used way more, so in the end you'll just still have a usage-based kind of payment model?
That is correct, and at the same time, pretty much all compute these days is a usage based fee model. Like when you're paying for services on Amazon or Cloudflare or Google Cloud or any of those, you're paying by the gigabit
Yeah.
per month.
Yeah, though what I'm not paying for is, well, if I just want to do a simple computation and I know that it takes around $5 of compute to do that on my traditional cloud or just my laptop, I don't know if it's actually going to cost $5 on a blockchain network.
That's true, and that comes down to like the predictability of fees and based on the fee market model of those particular chains. Not every chain has a fee model that is variable. Some networks have fee models that are completely transparent, predictable, and static.
But how do they then protect from the availability of just spamming that chain as a means of getting it down?
That's where you get into questions of scalability in a general context, and that's actually an open question for a lot of networks on how to solve that problem. There's definitely lots of theories, but whether or not things shake out in practice is a different story.
So basically, the whole scalability thing, well, my own prediction is it will be solved in 3 to 5 years. So I think people building shouldn't care about scalability, and you're basically saying, well, yeah, you still should.
Yeah, yeah, scalability is absolutely important. It's one of the reasons we're not having so much adoption that we could be otherwise having. Back in the early tens, it was really cheap to use like these early networks, and the capabilities were obviously a little bit less too for at that time because technology improves. But at the same time, like when it was cheap, there was a plethora of ideas being explored and things that you just wouldn't see anymore because gas is too high. Like it just doesn't make sense to do these things now. But back then it did. And so having that cheap block space, having that cheap execution fee, and having broad scalability are literally the problems to solve. If you don't solve those, you're not going to ever see that billion user adoption that a lot of people keep posturing about.
What are some of those ideas you saw early that you think are still intriguing today, or just are funny from back in the old days?
Funny would probably be like some of the early projects like CryptoKitties. Like that was entertaining to see. There were some actually like really early crypto plays that happened around 2015, 2016 that were just like really cool ideas that just couldn't take off at that time because like the technology just wasn't there. And that would be there was one project that was doing music streaming,
Hmm?
and they were actually trying to store content in like on the chain in a way that was not extractable unless you had like a key that you had paid for, and that was like basically on-chain DRM, and that's like you don't even hear people talking about that now because
Mm,
we're
you
all
still
into
do in
the
the Arweave space.
yeah. And
That's the only space where I've really seen it. Otherwise, it's just content locking the access to the MP3, while you can then just share the MP3 in typical ways.
yeah, and so like this was more research into the full like not just chain of custody of the files, but like actually like the raw decoding process so that the entire thing was wrapped end to end. And so these were like very novel concepts that were being explored that were very cutting edge on the research space, but at the same time the execution just wasn't it wasn't possible at that time.
Also, I think today we're still seeing similar things. Like just if you have a look at the streaming services and how many of their proprietary shows end up anywhere on the internet,
Oh yeah.
where it is so high quality that it can't just be a screen recording that is shared there. I'm not sure if there are any leaks, but it's also highly likely that you can just record the whole data stream itself and then have the high quality feed.
Yeah, I mean, at the end of the day, like, yes, there's definitely ways you can make it harder, but for every attempt at like making a better mousetrap, you're going to get a better mouse. Like, it's just the natural selection of entropy.
That's also a kind of a good summary of how the whole cyberspace in general, like security, execution, hackers, and that space works in general. Also with compute and just IT, I think, because whatever you're trying to do, there will always be new ways with new tech.
Absolutely.
Also with new tech, when we well, a little bit hinted about the privacy discussion of how you cannot open your book but still do all the compute. Um, you're working on a solution to that, right?
That is correct, yeah. Equilibrium is essentially trying to be a generalized compute platform that provides input privacy and end-to-end encryption for communications at broad scale.
So when I'm thinking about it, and that's also kind of the the prompt I'm always hitting you with is I just want to do my Kubernetes cluster in a CryptoPunk style. Because I think the Kubernetes cluster works well for what it is now. So for those unfamiliar, it is just a way of saying, oh, I want to run any kind of thing I want to do. I want it to be automated. There are strict rules that the Kubernetes itself allows me to follow, kind of like a blockchain does with the transactions, where I just define it once and then the cluster takes care. Like if it goes down, the cluster will guarantee that it tries to spin it up again. Same like the blockchain will just run your code as is. So if you write code that guarantees that, well, a stock market transaction gets done, the blockchain will guarantee that it gets done. If you have a bug in your code, the blockchain will guarantee that the bug is executed properly. Um, that's kind of a similar thing. That's kind of also probably why I like both. the cloud engineering and the blockchain stuff. And when you go into running any kind of workload, like what kind of challenges do you have? Because you hit a lot of negatives on the blockchain side as well.
Yeah. So obviously, yes, any bugs in execution are going to still be bugs that exist in the crypto side of things. It's something that we actually see even like on public blockchains that don't have any like super high tech crypto. It's just basically simple blockchain. In those cases, like you still get people getting wrecked all the time because like it's so much of the machine state's exposed that it's very easy to introduce bugs. Um, so it's not necessarily the problem of trying to prevent that. The problems that you run into in this specific domain are how do you handle developer use cases in a generally like applicable context that is sufficiently capable that most things can be achieved. And what that comes down to is things that are deterministic versus things that are non-deterministic. Like if I have an algorithm, generally speaking, that algorithm is using a some kind of series of events that are predictable. And if you were to formally verify it, you could. However, there exists a class of applications whose behavior is non-deterministic. They rely on some form of randomness, some form of entropy. I mean, cryptography itself relies on that randomness and entropy in order to function.
Yep.
And so, how do you provide that kind of entropy to an application that they feel like they can still securely perform their duties and be just as capable of an application that's not operating in this highly secure environment? So that's problem one. Problem two is how do you execute this quickly? Because the other side of this is what you'll see with a lot of ZK ledgers is they're like, oh yeah, you can do millions of transactions per second, except they take like 30, 60 seconds to actually execute because you have to prove it. And the proof takes time. Even if the proofs are cheap to verify and in aggregate, it still takes a lot of time. So it has to be fast. And then the last thing is how do you ensure that that actually works at a broad amount of scale? Because if you're just running one application, then there's lots of like clever tricks you can employ to take advantage of certain things about the structure of an application, whether it's like a particular multiplication that's being done. You can use a much more efficient algorithm in a secure context versus general compute. All of these problems you have to solve all at the same time, and that's definitely a balancing act.
So basically, the one issue problem tries to solve is we have just one general state, it's all accessible, and we try to somehow do the, oh yeah, it's provably deterministic, well then people come along and add oracles and all that because they need data outside of the chain, like spotting event data. And then what you're saying is, okay, well, you can actually run both in the same manner with the guarantees, being like, oh, it's private, it is verifiable and fast.
Right, like trying to solve for those problems is definitely almost its own trilemma, but at the same time, it's not as hard as it sounds. When you actually break things down into its core components of what you're actually trying to achieve, all you're trying to do is execute a circuit. Like, at the end of the day, your application is simply a circuit. It's like wires and gates, just like any logical circuit that computers are made out of. And so, if you can find a way to efficiently decompose applications into that logical circuit, you can construct proofs from them. You can construct multi party computation circuits out of them that enable several different individual actors to contribute their inputs privately. You can find ways to break it out and scale it out so that it's discrete units of compute, and you can even scramble them so that it's untraceable as to which node executed what or what nodes even know what they're executing. So there's lots of different techniques that can be employed, and you can start to add back in those other additional components you need. Like if you need on-chain oracles, you can come up with techniques that leverage that same form of cryptography with zero knowledge proofs in order to extract that data and prove that it was actually valid in its extraction, and then bring that data back onto the network, and then you have successfully closed the loop.
So when we talk about blockchain problems and the technology in general, you've now also solved the oracle problem in that sense.
Correct. Yeah, because when you think about it, when you open a connection, like say that you're talking about an oracle that relies on web feed data, like just HTTP streams.
Yep.
When you're in that scenario, how do you assert that that is valid? Well, the nice thing is that most things connect via HTTPS now, so you actually do have a certificate from the other side that is saying, yes, this is true. So what you do is you can essentially create a circuit that expresses the creation of those TLS frames, like those literal linear sequence of frames, those packets going between you and the other side. And you are essentially proving that the construction of that frame was valid. And from that, you now have enough information to assert provably that that content was actually delivered from that provider and was requested at this time as stated, as long as all parties have agreed to the actual terms of that construction. And as long as you do that, then yeah, you do solve the on-chain oracle problem, then you can have trustless execution.
And with the on-chain oracle problem, well, you're saying, okay, well, I can solve the actual data being honest, at least in the sense that I know that as long as the provider is honest, I
Right.
am getting the actual data. So what we then might do, that we're doing in the blockchain sense right now, is we just use however many providers we want, to get trust guarantees.
Yeah, and I mean, like all of this, even the cryptography side of things with these zero knowledge proofs, it all comes down to probabilities and whether or not those
Yeah.
probabilities are sufficiently convincing enough to be true.
And then you're also tying back into the whole, well, kind of game of economics. You talked about solving instead of building games, where games themselves are also probabilistic, while the economy is now, the whole cryptography is, and the proof itself is. Where if you have five providers and you know the chance of one of them trying to fix, well, bets, for example, in matches, in football matches, then you can also calculate, well, the other four are likely not to be corrupt, so then I can verify that as long as, we'll say, like three of the five I have a positive answer on, I know the result. And then if that gets spoofed, you can just add more providers and tweak it, is what you're saying?
Abilities and higher degree of probability that the accuracy of that particular price at that particular time or that particular statistic at that particular time, what people are essentially betting on, that that is a valid assertion of consensus.
So kind of the, well, whole betting market could be a means of getting consensus around something, where if the price of one thing is so low, we'll say you're betting $1 on somebody winning the election, and that party actually wins the election, then the price of, well, the reward you'll get for betting on them will be none or next to none, and then
Yeah,
so then you could also use, well, prediction markets as a data feed in that sense, to
yeah,
to validate.
and that essentially is what's happening. Like you see that in like particular protocols that don't use on-chain oracles, they just use their own market dynamics, and that has a problem, especially on public blockchains, because now you've
Yep.
introduced a gameability factor, and so you end up with like these sandwich attacks that end up wiping out like novice investors that don't understand that the public blockchain is a dark forest, and there are definitely monsters lurking.
Well, for those unfamiliar, sandwich attacks are kind of the front running that's been going on in markets for ages. Where if you submit that you want to do something and I know it before you do and I can profit off of it, I will. So I'll just make sure that I'm doing something that benefits me before and after. So say you want to buy 10 ETH, on a market, and I manipulate the Ethereum price to give you worse execution and bank the profit, then you've basically been screwed, and that's what we're referring to here.
Yep.
Was that an issue in the early days? Because I probably can't think so, because it was too little people in there, and not easy to work with.
No, in the early days, it was a problem then too. That's, I mean, if you look at Uniswap, for example, they went to V1, V2, V3 really fast. Like in the history of the protocol, they sped run that pretty quickly, and a lot of that comes down to, especially V1 to V2, was just like naivete about like when there is any advantage to be gleaned from public information in terms of markets, like it will be gleaned immediately. Somebody who has enough smarts to take advantage of it will absolutely do so.
Which would then tie into the efficient market hypothesis that, well, the markets will be as efficient as they can be, while in blockchains it seems like, well, that will never be true just because you can front run anyone.
Yeah, and I mean, like, that's not necessarily true that you can front run anyone. There are, for example, there are RPC endpoints for Ethereum that you can talk to instead of talking to just the general public mempool of transactions that, promise not to snoop on your transactions and extract value from it.
Well, so what you could do, tying it back to the things we do outside of blockchains, is you just have your own or just some provider that says, well, yeah, I'm just running that for you in a way that no one else can see. And that way I'm not getting
Until it
front run.
settles.
But you could also use your own validator and just blockchain node to then just submit your own transaction. But that would only work if you're the actual one building the whole block, like constructing the whole thing. Where then you could also be the one front running anyone else, and that's how kind of like how the thing works. Like if you're the one constructing the block, you're the one actually making the choice.
Yep.
Isn't that also an issue in Equilibrium?
It is not. So the execution model in Equilibrium is a little bit different. For starters, all transactions are private. Inputs are private, so you can't see another person's inputs. The only thing at best you would find out is based on the sequence of events if there was any locking that came into play that caused two transactions to have to be forced into a particular order. That would be the only scenario you'd run into. But even then, that's not something that's predictable or analytically accessible to somebody who's executing a transaction. It's just how things settle. So this is actually something Ethereum has looked at. I don't know where they're sitting at on whether or not they're going to adopt this, but there's essentially this technique called a random permutation matrix. And what that essentially lets you do is it takes a linear sequence of events and scrambles it. And that scrambling is essentially a relatively non-deterministic sequencing. And what that gives you is essentially in this like Mev world where you have people who are front running each other, you can't front run each other because you can't predict where your transaction is going to land. And in fact, the presence of your transaction is now actually re-influencing the randomness in the ordering of events. So you really cannot predict the sequencing of events and how that's going to play out by the time it actually settles. We use this for Equilibrium, not for actually providing like anti front running behaviors as much as we actually provide it for analytical privacy. So the way things execute on Equilibrium, are you familiar with Tor at all?
With the Tor network, yes.
Yeah. So the way things work on Tor is you're basically hopping from node to node in order to
Yep.
obtain some degree of privacy about the things that you're accessing on the web. The problem with that, and something that we've actually seen a huge spike in recent years, is you have state actors that are actually running some of these nodes. And so by consequence, you actually have a large portion of the network that is essentially compromised and is watching traffic and making associations based on timing. And so that same problem maps over into the crypto space in the sense that you have a large portion of the network that is visible if you have a large amount of compromise. And by consequence, you would have traceability of transactions. Regardless of their privacy, the privacy doesn't matter. If you can get enough analytics to associate A to B, then you have now, at least got some kind of useful information, especially for a state actor. Like metadata is immensely valuable. They care less about the conversations. And so, by consequence, you have to actually also solve the problem of that timing and analysis. And so, what we use the random permutation matrix for is essentially to break that link. Even if you are a like significantly malicious actor that is running a bunch of nodes to monitor traffic, the presence of the random permutation matrix actually prevents you from, at the end of the day, being able to create that analytical link.
And that happens because, from what I just understood, is because of the randomness at maybe one node, for example, before it gets passed, you don't know the exact order in how it's going to go. So if you try to trace it back, you don't know where it came from, just because you don't know how it was permuted there. Or how
Correct.
does that work? So you're
Yeah.
basically on every hop scrambling it.
Yeah, sort of. Like it's actually a multi-leg hop process, just like Tor. And in that multi-hop process, you also have nodes working together to create a logical random permutation matrix. Each node is creating its own random permutation matrix, and there's essentially validity proofs that assert that that RPM was generated validly. And then by consequence, when you merge them all together, random permutation matrices of the same size, you multiply them together, what do you get? A random permutation matrix.
Yeah.
So by the end, that calculation is performed. You have that deterministic sequencing of ordering, but with the non-determinism of being able to actually know which transaction was which.
And then in the end, you can also verify that it was all true because you verified each individual matrix, and multiplication is non destructive in that sense.
Correct.
And then if you can verify, well, yeah, this is basically how it's going to go, doesn't that also impact the actual execution? So if I'm saying, well, I need to buy Ethereum first and then swap Ethereum for some other meme coin I want to buy, in that network setting, just to stay with that computation example because I couldn't come up with anything else. Uh, if you do that, then you would the case would go where you said before that I can actually enforce that order to be true.
Correct. So there's this notion in Equilibrium of essentially dependent chain of transactions, because the execution model is very different from Ethereum. Like Ethereum, you have a function call which may impart other function calls, and those function calls may impart other function calls. As long as you pay enough gas, it completes. As
Yeah.
long as you also don't exhaust the gas of the block, which we're seeing that one meme token, was it called Zen, I think. Like its sole purpose is to just consume all the gas of a single block. um, but in the case of Equilibrium, the purpose here is that you actually declare the dependent chain of transactions that you need to execute. So you simulate the effects that you need to create ahead of time before you actually create those effects. And by consequence, you've created that dependency graph, and you're simply creating a dependency graph that you're telling the network, go execute this.
So it's basically all graphs then, where I can just say, okay, those well passed in the graph can't be scrambled again.
It's not that it can't be scrambled. It's that the layer in which the scrambling is occurring is a precedent to that. Like it's ahead of the actual graph execution.
But how deterministic do I get then? Like when I'm saying, okay, I just need to know that my computation runs, say in whenever, and it actually keeps the order. It isn't like how does the randomness work with the traditional way of thinking that, oh yeah, I'm just going to post whatever computation I need to do and it will get done.
Yeah, I mean, from the end user's perspective, they still see this as I'm calling a function. How it actually executes on the network is something that's very decoupled from the user experience. That's just essentially the implementation details of how the network works. So from the user's perspective, they do see it as I'm essentially invoking a function, or I'm using a service on the web, depending on how distant they are from the actual operations of the network. But down at the actual execution layer, it is essentially a graph of compute that is being distributed through the network in a deterministic way.
There's so much more detail we could go into even with just the graphs, because what you could do with just the graphs, because you're now basically just in graph theory where you kind of and yeah, I'm putting that in quotes for anyone who doesn't look at the video, because just in graph theory is kind of a well, bold statement, um, but then you could also verify those graphs. So if you just have acyclical graphs, you could then just have a full formal proof of the whole computation where you can assure that there are no bugs. Like the only way in software where you could assure that there are no bugs and that it doesn't hold is if you just don't allow loops, and you just have, or just don't allow infinite loops where you can know that, well, yeah, now I actually have a graph that terminates. So you could technically do that.
And that's actually what's happening on the Equilibrium network side of things. We do not have infinite loop capabilities, but we also don't have like the same kind of gas model that Ethereum has, where like how it executes determines the price. Like ours is actually static based on the amount of compute being performed. And the executor, like the actual execution part of the network, is receiving a garbled circuit that contains the full actual application execution that has to occur. So at the time that circuit is being created, you already have defined the bounds in which that compute is being performed. So if you have a runaway loop, you would never complete this. Like, it has to be a finite deterministic sequence of events. And if you're writing an application that doesn't do that, well, then you're not going to execute it on the network.
So basically, you can't just do a cron job checking, okay, this is the timestamp, and please ping whoever on WhatsApp at that time.
So we actually do have the notion of scheduled events, but those scheduled events are predefined in advance. The circuits that are being constructed are defined in advance. And so if you are running into the scenario that you need to do something non-deterministic at a deterministic time, that's still not something you could do on the network.
So, but then you could say, well, okay, yeah, please, dear network, run this deterministic function that then makes the non-deterministic call, because that would be deterministic in that sense.
No, non-determinism is something that you just simply couldn't do. You can simulate non-determinism, but you cannot actually have non-determinism. The only thing that would be non-deterministic would be the use of what we described earlier with that on-chain oracle process.
Yeah.
That process is deterministic. The inputs are what's non-deterministic. And so as long as the inputs are the non-determinism part, then you're okay.
Okay, so when we break that down for, well, people like me to actually understand it, that means I can input whatever I want as long as I somehow generate the input outside of the actual network.
Correct. Yeah. So one way to think about this is like, if I was writing a blog post, that is
Yeah.
non-deterministic because I'm a human being, and human beings are relatively non-deterministic entities. And so I
Yeah.
provide that input, and let's say I was using Rwave, I would literally put that content onto the network. Um, the act of placing that content on the network is deterministic, but the content itself was non-deterministic until it settled onto the network.
And then the actual data is what's non-deterministic, but how to store it is known.
Yeah.
Kind of like when I'm training somebody in industry to, well, make jewelry. I know the whole process of making jewelry. I just don't know what exact piece or stones or whatever I'm going to use for that.
Yeah.
So what kind of applications does that enable, and what kind of applications does that, well, disable?
So, in terms of enabling applications, pretty much any application, you follow a deterministic set of rules. The only thing that doesn't work out there is things like, I need a true source of randomness that is for, like, say that you're generating a public key or a private key, for example. When you generate a private key, you are relying on huge sources of entropy on your computer or your hardware module, whatever you're using, to generate enough randomness that you feel statistically secure. Um, in the case of on the network, you wouldn't be able to do that directly. You would have to change the way you're approaching the problem, in that randomness is now an input instead. So as long as you change the way that you like actually construct your application such that all non-determinism is an input versus a nature of execution, then it can execute on the network.
So if I go back to my simple IT mind where I'm not smart enough to do any of that and just don't want to even think about it, just as an example, I can do whatever I want, run it, as long as the only thing I worry about is giving inputs.
Yeah, I mean, like when you construct an application, generally speaking, unless you it's something that you explicitly know that you need randomness for, you're not really going to run into non-determinism most of
Yeah.
the time. Like, you might have some things that are relatively bounded in indeterminism, like, what is the current time? Like, if you need to know what the current time is, then okay, that is something that's technically non-deterministic, but you can reasonably create a deterministic model that gives you a time. So those types of small non-determinism problems are easily solved, like easily addressed by the network.
But then with the time example, that's an interesting one, because time can, I can write a program today that could theoretically also run in 100 years, and then if the time is an input, I still have to verify that the, or just make the one using it make sure that the time is shown in that format that I specified 100 years ago? Or does the network offer a solution? Because time is probably not the right example to ask for a network, because that's so well, widely spread that there likely is a network version. But in general,
Yeah, so the network actually does have a facility that reconciles what the current time is. And that's essentially again, we're getting back into probabilities, but it is a
yeah,
probabilistic function based on what most nodes are in that local cluster are asserting to be the current time. Um,
time zone agnostic, or
Time zone agnostic, of course, yeah.
okay,
Uh,
okay.
we're working off of like Unix epoch time. Like we're not doing anything particularly fancy there. It's just based on what the last few snapshots of frames were, which frames are equivalent of a lot of networks, what they call blocks. Based on the local frames that have been accumulating, what is the current time probabilistically?
So I can't exactly know during execution what the time is in the second of, or like millisecond of execution, but I have a general range of time. So if I were to constrain myself to minutes, I'd likely be fine.
If you were to constrain yourself to seconds, you'd be fine. It's a matter of milliseconds that the granularity is going to be not deterministic enough to be correct.
Well, then you're already way, way, way faster than anything with those kind of security guarantees or guarantees that it's going to run the way I actually want it to run is right now, if it's just milliseconds.
If it's just what?
If it's just milliseconds.
Yeah, like we can't get accurate measurements in the milliseconds. Like that's not going to be correct. But what you're going to get is essentially a snapshot of asserted time that is within the range of like a second or so
Yeah.
is accurate. Yeah.
Are there any like use cases where you say, okay, this would be something that would be really cool to build on a network like this?
Yeah, I mean, like the whole reason that I had built this network in the first place was because I had seen two big problems that I wanted to solve. One was deplatforming, which is like when Amazon says, "Oh, you're politically inconvenient," and pulls the plug on you, or in the business context, you have two parties that really need to like reconcile some truth, but there's no substrate on which they can do that. Like you see companies get hacked all the time. Like you have data brokers that, will funnel data between two parties, they get hacked. And now suddenly thousands of companies' private data is now leaked. And that's just a non-starter. So if you have a secure substrate that is essentially the plumbing between all of these discrete businesses that enables you to trade your business objects over like you were doing anything in basic accounting, that's a very powerful tool. So those are the two big problems that I wanted to solve, and that's what I basically solved with Equilibrium.
And starting with the first one, the deplatforming, is there a legal framework that allows you to host anything?
So that actually comes into an interesting problem. Obviously, when you get into content hosting, there is depending on your country. I know Germany's got different laws than the United States
Yeah.
about that, but in the United States, generally speech is protected. Where speech is not protected, though, that's where some interesting nuance happens. And in particular, when it comes to content hosting, there is one particular form of content that you just simply cannot host. There's strict liability around that. And so, can you solve those problems? Yes. Can you solve those problems and preserve privacy? Also, yes. And so, the way that you can actually achieve that is through basically a content detection technique that Apple was originally going to use on their iPhones, but it ended up being unpopular, which is ironic because they do it they do it in iCloud anyway. So like users were already like dealing with it and just didn't know. Um, but yeah, essentially what you do is essentially a private set intersection technique that leverages perceptual hashes in order to detect that content. Everything else is fair game because at least in the United States, because freedom of speech essentially asserts that you are free to speak your mind. That's not there's no restrictions there for the most part. You do get
Yeah.
into little bits of nuance, but for the most part.
If you're in Europe, free speech is a totally different discussion in many senses, and I won't go into any detail because then my personal opinion will likely influence a lot of what I'm about to say. Um, where I am way more just let anybody say anything than the European consensus and politicians especially. Uh, but because I'm just like, well, if you don't want to see it, just force any app to have a mute list. Like on Twitter, I had to block any kind of recent event related war country names because it was just too much. Like I follow people for tech. I appreciate you if you've been hit, and I will tell you and reach out to you to see if you're fine. But I just don't want to have my feet blown over because that's just not what I'm interested in. And in Europe, there could also be ways where then the actual platform itself has to enforce certain things and you have to be compliant with law because in Germany, the actual first article of our constitution is that the human honor is untouchable. So then this is just what it states, and then you have to be careful. Well, what wording would be in a way that actually goes against that, and what wording is just a general means of saying it's I think person X is a bad person, and that's where you get into really fun thing. Especially in Germany right now, we have a little more of a right wing coming up. And 5 years ago in Germany, you couldn't even say anything against immigration, and you would have likely been, at least from public consensus, you would have likely been blocked from saying that on a public network like Facebook and so on. They were heavily, well, pressured to remove certain kind of contents. Well, nowadays, this is a public opinion that around a third of Germans actually share publicly. So if you're walking around in the store, you can now say things that you would have been thrown out of the country for defamation five years ago. So even with that change, like how can you even incorporate that technically?
Yeah, and so that, like, from the perspective that I operate from, I actually consider like the free and open discourse of ideas to be something that is paramount to a free society. That's where we're getting into deeply political opinions, and so it's really hard
Yeah,
to disconnect those because it is intrinsically related. But when you actually get down to the core ethos of crypto is a deeply political statement. Like it
it
started
is.
with the message that, like the chancellor on the brink of the bailout of banks, or whatever that exact Times headline was.
Europe again.
And so, like, the whole of this was very much a political statement, and so it's impossible to decouple the two. But when you do get into the nuance of law, generally that responsibility falls on the shoulders of the most responsible party. And that sounds like a cop out, but the reality is that if I'm hosting something on Amazon, Amazon is not responsible for my actions. I am responsible for my actions. And so, in the case of like me choosing to ignore that responsibility, Amazon could then potentially deplatform me. What they've kind of shown historically is that it's not so much about the responsibility as much as it is that it's now inconvenient for them. So that's where like my own opinions get into the mix of like I have problems with that. But when you dive into like with respect to other countries' laws, if I'm a forum operator, like I have a message board,
Yeah,
and somebody is not just posting things that are aligned to like AFD on that message board, but they're going like really really extreme. That would be something that I, as that message board owner, would have to actually handle. um, that's not the responsibility of the host of that message board if I'm using a third party hosting service. And so very similarly for Quillibrium, we are an American company. We do have to adhere to the laws of this country, and if we gain presence in other countries in terms of institutionally, we would have to
yep.
follow those laws as well. But the responsibility that is on us is different than the responsibility of the people who are actually creating that content and hosting the content on the network. Because what's different for us compared to a lot of other networks is we do have a state rent mechanic. So it's not something that you can just put there and it lives indefinitely. You have to pay to keep it on there. And so that's also another measure that keeps at bay like somebody who's just wanting to cause problems.
But if I'm the one just being publicly funded because my opinion is shared by more than one person, and that would be, I'm just taking the Germany example because that's the easy one we already have, and then the German agencies want it to be down. If then somebody from the US is like, I'll just take it over, it will still be on equilibrium. Well, then the German politicians, what they typically try to do is nowadays go to EU courts, also to German courts, and try to ban that whole platform and thing from ever like having existed or existing in Germany.
Yeah, and I mean that's kind of the core principle of decentralization is that the internet perceives censorship as damage and routes around it, and by consequence, that's the truth for equilibrium as well. Is that if there is some like legislative force that's simply just saying that this network is untenable, it's unacceptable for our nation, we're banning it. Well, you can't really stop it. It's like trying to stop people BitTorrenting files, and so by consequence, it will continue to route around you through whatever means you're trying to employ, and that comes back around to the philosophical trade-offs. Like, do we want to engage with censors in a way that's actually cooperative? And to me, the answer is no.
So then, well, as a German citizen, I couldn't run a node that would host that content legally, but I wouldn't know because it's encrypted.
That's the thing, is that the content is not only encrypted, it's sharded. So there's not actually any ability for a node operator to know what content they're hosting unless they actually have the key for that content.
Um, there's a legal precedent for that in terms of torrent networks earlier, where in Switzerland, what happened, not Germany, but close enough, what happened is the largest torrent networks were set up in Switzerland because they were legally fine to do so. And then the whole like authorities came and were like, oh, can you please prove that you're not doing anything illegal? And they're like, nope, we don't even have the keys. We can't even inspect it. Um, and then there was a whole cat and mouse game between the actual governments and their agencies and the providers, where the providers are like, it's zero and ones. Feel free to have a look and try to decrypt it. If you can, please let us know because then you have broken encryption. Um, and this is actually a full-on discussion that happened for a couple of years in Switzerland, where through university I was able to speak to some of the people building the hardware modules for the actual encryption and the random functions to build those public and private key pairs. And they just use technology that they have used in banks all over. So they could actually run tens of thousands, hundreds of thousands of encrypted transactions per second. So they had specialized hardware modules at the like bottom of their server racks to just be able to do so. And then you're getting into the legal ways of, well, should this be legal or illegal? Should you be able to have to know, kind of like the know your customer space? And then every country is likely different. But regarding to equilibrium, you'll likely be like, oh, we never know, we will never know. Just use a VPN if your country blocks it.
Not necessarily use a VPN. The nature of the network being so widely distributed from its very inception. Like we're currently running about last time I checked, it was like 800 nodes. So even in our early days, we've got very wide distribution, and there's nodes all over the world, Europe included. And so by consequence, it's I don't mean to like sound like a provocateur in this, but it's definitely one of those things that's like, how do you stop something that's already deeply present everywhere? And so, like, yeah, you can have laws induced. You can say, like, ISPs detect this traffic and block it. But at the end of the day, when the traffic is indistinguishable from any other service traffic, can route on any port, can be sent through any channel, it's actually incredibly difficult to block something like that.
Like, that is also really interesting in terms of the peer-to-peer architecture. Just to hint at that a little bit, where you don't even have a central entity that could even control or manage that in terms of the network.
Yeah, our network launch was actually a totally fair launch, so that even myself, like I have no capability of asserting control on the network. I have no ability to, and I know that this is a problem with a lot of crypto projects. I have no ability to rug the network. I don't own a significant portion of the network's token, and there's no governing stake kind of mechanic to it anyway.
But then, how do you actually make sure that the protocol still develops in the sense that you envisioned? You probably can't, right? Besides the technical upgrades, where as
Yeah,
of right now, you're probably the like main developer, but in the future that could also change to be like it is with the Linux kernel now, where you have so many parties actually developing on it.
Yeah, and that's the beauty of open source and decentralization. Like if I were to ever take things into a direction that violated the original premise of the network, like if I were to induce like some form of censorship and control of the network, well, the network can reject that because it's open source and people could fork it and distribute their own fork and essentially sidestep any attempts at actually censoring or circumventing the network.
Also, if people want to look up an example of that where a large provider actually wanted to sidestep a network and the network rejected it, Google Arweave and Iris. That's not an actual like I, but the third to last, no, the second last letter in the alphabet. I don't know the English word epsilon, whatever, instead of an I. Where what happened is that the Arweave community got wind of the provider who actually just uploaded 90% of all traffic to this data storage solution called Arweave. And people are like, nope, you're not going to have us go on your fork and use your token now. We'll just change provider on you. And they dropped real quick, like in a couple of literally days, like it took 2 or 3 days at most for their market share to drop so deep that I'm not sure what happens with them now, but they didn't even have open source code for the little things. So people have just now used different tooling at all and went back to open source stuff.
Yep.
Uh, which is also for those who think it's just a blockchain phenomenon, what happened with Elasticsearch. This is one of my favorite examples because it's in the cloud space and so funny that a large player like Amazon was like, "You're not closed sourcing the thing we use and have our customers use." Amazon is still pro customer in that sense. It just also is pro Amazon, um, which is probably where you are with Equilibrium being like, "Oh, pro Amazon is sometimes not pro me or pro what I want and my values."
Yeah, and actually, it's funny you mentioned the Amazon case because I can empathize with Elasticsearch's problem in that they had an open source project and Amazon was directly profiting from it and essentially diverting the profits that would have otherwise gone to Elasticsearch as a company. I can empathize with that, but there's a better way to do it. There are open source licenses that are essentially poison pills for Amazon. Things like the AGPL. Like Amazon cannot release AGPL based products as their own managed services because if they did, they'd have to open source all of AWS. And so
Yeah,
that's the best loophole is that something that's infectiously open source, something that essentially asserts that if you are going to make a profit off of it, any contributions you make, you got to kick back.
the interesting part about those license discussions is you're getting into the whole anarchy part of open source and crypto again, where they're so tied together in that whole spirit and mindset thing. Where if you were to use such a non-permissive, and crypto people will call that, and open source people will call that non-permissive license, where I can't just use your code for my own commercial use, then you're getting into the discussion of, well, should you even open source it or not? And then how do I even know that you're running that thing? Why should I even care about it being open? I'm just developing your thing. But that's a whole discussion I found really interesting because then if I open source my stuff and private people can use it as non-profit, businesses would then still technically need to pay me or arrange with me. So where
Yeah.
would you then go and be like, oh, should I open source it or not? If that's my concern.
I mean, if your sole concern, like your sole business, is strictly on the commercialization of your software, and that's it. Like if somebody were to just take your software and start reselling it themselves, and that would kill your business, well, then you shouldn't have open source software. That's not a viable business model. But if your business is based around the services, this is such a hard word to come up with. Serviceization, like making your service your commodity, like the nature of your business, rather than the actual software itself, like managing it, deploying it, making it easier to use, whatever. Those kinds of things. If that's your business, then open source is actually a very beneficial model because now you could have potentially a dynamic marketplace where other players could also have their own commercial entries. and be contributing back to that code base as a mutually beneficial and reciprocal benefit to the product.
One way I found of making open source commercially viable as well is just providing a guarantee.
Yeah, absolutely.
Because especially in Germany, many of the big companies want to have public contracts, and those mandate certain kind of business standards to follow. Like, feel free to look up the ISO standards, PCI DSS for credit cards, and all that. And they require you to have a warranty. Well, how do you get a warranty for a small little library a single developer developed? You can't. Most of that is MIT licensed, so there's no warranty. But if I then, as a provider, go ahead and I bundle those, provide a warranty for it, then you have to pay my warranty, and I can still just kick it all back in terms of development time to that open source project, which is really, really, really interesting. And also, like, getting back to the blockchain space, where to me, sorry, but Equilibrium was way too interesting to not dive deep into that. Like, my understanding of the technical is still way lacking, but I'm sure that, like, developers could probably understand it. Might have been too deep for the non-CTO people, but for blockchain in general, like, what do you think is the core problem, or like the product market fit that it solves?
So the existing crypto networks, the ones that have been around for several years now, um, if all you're seeing on them is just more rehashes of meme coins and general like focus on tokens, like focus on like somebody creating pump and dumps, things like that. If your network is really only succeeding on those characteristics, it comes down to it being a consequence of the design of the network. There is so much potential for applications to exist in a decentralized way, leveraging the advantages of a decentralized distributed ledger. But if you're literally only seeing that, that's indicative of a scaling problem because it basically means the only application that succeeds on the network is one that is strictly correlated with financial ramifications. And so that's kind of the big problem for a lot of these networks is how do you escape the like strict relationship to financial transactions in order to do something more? Because if all you're doing is just making programmable money, then that's great. Like we've solved the programmable money problem. Now how do we solve the general compute problem now? And like if the goal is Ethereum is supposed to be the world computer or Solana is supposed to be the world computer or any of these, if that's supposed to be true, it needs to do more than just transactions.
That's where Ethereum goes to the true. Solana goes to, like, we just make a better network over time. Bitcoin goes to, we will just be global money.
Yep.
Well, then you have monetary theory, where we sadly don't have time to dive too deep into that theory of 21 million coins being enough, where you can technically then go and split it up into the, like, oh, now we're using like a millionth of a Bitcoin as a unit of sale, for it to be kind of not inflationary in Bitcoin terms, but inflationary in the daily use. So if I pay, for example, 1 Bitcoin for a pizza in 2012, now I'm not paying 1 Bitcoin, where Bitcoin is considered to be worth a car now instead of a pizza, just to make it time agnostic. And then you can have those kind of discussions about monetary theory, but Bitcoin technically says, well, we're just a payment network. But then can you interoperate between other just compute focused networks like Equilibrium and Bitcoin, or how would that work?
So it's kind of interesting. Bitcoin itself has been very resistant to interoperability for the most part. Like every single time there's been any attempt at putting something on Bitcoin or interacting with it in a way that's more than just like wrapping Bitcoin and transferring it, it generally doesn't. I don't know. They resist it pretty strongly. So, would Equilibrium be capable of interacting with Bitcoin as a network? Sure, no different than any other like out of network Oracle type thing. Like if you create the connection and use the zero knowledge proving circuits to verify that the connection was valid and that the state that was transferred over was valid, yeah, great, you can do that. In terms of like will we ever directly commit state to Bitcoin as part of the network's functions? No.
Oh no 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 no. That Bitcoin doesn't work, especially with scaling wise. Like we talked about scaling at length earlier, so that no, Bitcoin is not scaling in that sense. But you could then have Bitcoin as like a payment service in the network, as long as the API would provide zero knowledge proofs that could be verified in Equilibrium, where just to make it abstract, because I first of all don't know all the technical details you do, but it also makes it better to explain. Where if I'm sending 10 Bitcoin to you as part of my execution on Equilibrium because I'm building a payment processor through it, then as long as you get the proof that I sent that Bitcoin on Bitcoin and it is also settled there from whatever API, we can go back to the Oracle and be like, okay, this is fine. And it's also deterministic in the sense that you just verify the proof, verify the API call, and are good.
Yep.
Is there something building on Equilibrium where you think, oh, you haven't expected that?
I mean, when you say the network is a general compute network, and you're expecting to like our big hairy audacious goal, if you were to call it that, at Q is actually to in the end, like we'll have succeeded on our goal if we have consumed all of Amazon Web Services business. And so for us, like we'd be more surprised to see that something is just totally non-viable on Q rather than that there is going to be a surprise of what is particularly uptaking it. That being said, I have seen two particular industries that have really resonated with it, even very early on, and those two industries are social media. Because a lot of them have problems with content hosts, like content hosts deplatform them because of various reasons. And the other side of that is people who or companies that explicitly like understand the need for MPC and need it now. So that would be like, service wallets, like any type of wallet as a service type provider could find great immediate value in Equilibrium because MPC is hard to do. But if the network already does the MPC for you, then your problem is just implement a basic application. You don't have to think about how the MPC is actually working behind the scenes.
So, in that sense, to abstract it for a business, what you would do is you would say you have a login with whatever you want as a login. Then your private key is somehow on queue, and I can use that as a signer for my wallet instead of using AWS's Nitro key.
Yeah, that is exactly one of the common use cases. And I mean, generally, like the use of Nitro for these wallet service providers, they can't just have the key managed through Nitro, because if they do that, there's lots of compliance obligations that they are still beholden to because technically they're still custodying the key. So what they end up usually doing is some form of key splitting and then either recombining or doing some kind of like MPC operation. But generally, it's just recombining shards inside the Nitro. That's a little hand wavy about whether or not that's actually like sufficient under a lot of these regulators' purview, but that's what a lot of them do. And so the way to basically solve that ultimate burden is to actually have a general MPC compute grid that all parties involved can just plug their data into, and it will execute transparently.
That's what queue does. So you can actually get the guarantee.
Yep.
That's really really interesting. And in general, for the whole space, is there something where you're saying, oh, this is something really really cool, and that's like the opportunity to dive into besides what you're already building?
Something in the industry that I think is really cool, like
Yeah,
outside of Q.
yeah, obviously, because otherwise you'd say queue.
Yeah. I think probably the most interesting thing that I'm seeing in the space that I, I say interesting because to me, like a lot of the space is about financials. And so seeing something that is starting to actually gain some adoption that's not directly related to financials is actually the integration with gaming. Like the amount of like these new games that are popping up that are starting to actually be stellar. Like they're not like just these like hacked together, Saturday afternoon like crap code project that just happens to interact with the chain. Like these are like AAA studio level games that are starting to emerge, and that's really cool. I harken back to my childhood there, like seeing the video game industry starting to adopt Web3 in a general context is actually really cool.
So as long as Q gets big enough, you'll likely go back to your childhood days and build games on top of Q.
Hey, like the best thing you can do in life is live your childhood dreams.
And to just learn about all the depth we covered, is there any good guidelines, things, favorite resources you have? Obviously, the Q documentation that you're working on, but in general,
In general, I actually am a big fan of Schneier. So, like, if you're getting into like general like explanations that are public friendly for things about cryptography without actually diving into the deep details of it, love that. Um, but if you do want to dive into the deep details of cryptography and learn a lot more, your first like the first point of entry, the best one is CryptoPals. It's this nice little challenge based game where you're working through the motions of like understanding the actual security ramifications of cryptography and how it gets broken. So you'll actually be implementing your own, then breaking your own, and then implementing like things that actually make it secure, and then breaking those things, and it builds up that fundamental knowledge. But if you're talking about in just a like general crypto sense, honestly, I actually like Masari.
that's interesting. Like most of the people were just like YouTube, search YouTube, um, that I've talked to so far and just figure it out instead of being like, okay, I actually have this publication that already breaks it down really well.
Yeah, I don't like. I'm personally not a YouTube person, and I know that this is a recorded video, so that's kind of ironic. But like, I like to get my content in text. Like
Yeah.
I'm just old now, so I need my text content. And
No, I also plan to incorporate text somehow. Like there's a transcript, so I can likely also just publish full or just curate a little bit and go into text form. It's also just a matter of time as well.
yeah, I always find myself when I'm watching YouTube videos, I run it at 2x or 4x speed because I don't know, I just lose focus. But so yeah, I prefer text content, and I also prefer text content because it's easier to see the mathematics. Because a lot of the understanding and deep details of this and getting how it works is understanding the core mathematics. And so like the expressive language of mathematics speaks best on paper to me.
Wait, so then in video form, like most of the stuff you consume is probably then also so deep mathematically that then video makes little sense.
It's not that video makes no sense because, for example, Three Blue One Brown, fantastic
Yeah,
YouTuber that is really good at breaking down math problems for audiences. It just doesn't resonate with me. I like text.
yeah. It's one of those YouTube channels that in university is all the rage for. Oh, you actually want to pass the subject? Yep, this series
Yep,
way better than the prof.
absolutely.
Awesome. Thank you so much, Cassie, for joining. We'll have your Farcaster in the bottom. We didn't even get to touch on that whole Farcaster set of things, but I'll just leave the link in the bottom so anyone can, like I said, go into the cast and replies, which is probably I think your most interesting tab because the root casts are I think just prompts, while as the replies is where most of the detail is hid to
That's
dive
true.
into.
I also have a lot of memes that I post. If you just go to the like cast side of things, so yeah, the replies definitely makes more sense if you're looking for deep technical content.
Yeah, no, that's just what I do. Like every couple of days, I'll just check Cassie or cast and replies to see anything I've missed because now Farcaster is getting to the point where I can't see anything that just gets posted on the home feed anymore because I'm just not also on 24/7. So that's what I do.
That's fair.
Do you have any closing thoughts? Anything you need to get off your mind?
I think the thing that stands out for me is just like it's going to be very interesting to see how 2024 goes. There's a whole lot of new innovations that are coming to the fore. Lots of very interesting like situations in politics and economy that are likely going to hit their grand fervor that year. And so, yeah, 2024 is going to be an interesting year, and I hope we all manage to survive the ride.
I hope so. I hope so. A lot of people in crypto have like many different opinions on how that's going to shake out. So it's interesting.
Absolutely.
Thank you so much for coming on.
Yeah, thanks for having me.
I'll just stop. Thank you for listening, and thanks for the guests for coming on to Techsuite for the C-Suite. In the description below, or the show notes, whatever you want to call them, you will find the awesome resources our guests mentioned to get you started. You can find links to our guests, and you all can also find a summary, takeaways, and other links to keep connected with the show. Thank you so much for listening. Have an awesome day.